guys, as you can see from the board, today's topic is 2D projectile motion, right? So we're going to talk about the general concept of it, what makes it up, and I'm going to give you some examples. So let's get started. Before we can talk about 2D motion, we have to think about concepts that bring in from 1D motion, right? So let's talk about vectors, right? What is a vector? A vector is something that has a magnitude and direction. So in today's video, the vectors that we're going to be talking about are velocity and acceleration. So let's draw a vector, right? So in 1D, right, this is coming to my y-axis, this is my x-axis, right? It's just magnitude. So this is its magnitude, and its direction is going to the right. So that's that. Or you could draw it like this, right? Like that, right? Its direction is up, and its magnitude is this line. Does that make sense? Okay. So this is 1D motion, right? If we were to analyze this motion, we're going to be like, if this was a velocity, right? We're going to say, because what is velocity? Velocity is displacement over time, right? Velocity. So it's going to be, right, it's going to be like things like, this is 60 meters per second. What is this, like east? Right? So it has its magnitude and its direction is east. Right? Or we could say, right, let's go there. I'm traveling in a car that's going 60 meters or miles, whatever. Let's do meters per second north, right? This concept of direction and this magnitude with an E, I forgot that, is what makes it a vector. Okay? Same thing with acceleration, except it's like going to be acceleration constant, which is going to be the velocity over time, right? Which velocity already has a vector quantity, so it's, it's going to be meters per second squared north. Or whatever. That's that. Okay. So let's talk about, so this is 1D motion, right? It's going in one dimension. So what is 2D motion? You guessed it, it's something that has aspects and components of both directions, right? So, right, it's going to be like, I'm going to go up the y and across the x, right? So like that. Right, it goes up and over, like a parabola, like me throwing a ball. So let's go through an example. Kobe. So I've been learning that I have an amazing jump shot. From that last example, let's understand the physics behind it. So, right, let's draw our little axis. Right, this is our y and our x. So this is how we're going to analyze 2D motion from an everyday thing, right? Everyone throws paper in the trash, throws a ball, launches a basketball, lots of things, right? It's all 2D motion, right? Because what did I do, right? I threw it at some angle, right? Call that theta, with some initial velocity, vi, and it went up. Oops, that's not a very straight line. It went up, over, stopped for a second, and then went into the trash can because I'm really good at trash basketball, right? So let's analyze my motion using 2D projectile motion physics, right? So let's analyze it here, right? So what's happening from here to here, right? Let's do this point. So my x component of my velocity, so my vx is there, right? And then I have some y component of my velocity, right? And then the curve, right, the arc that it's following is the sum of these components, right? And let's analyze it right here too, right? At this point, right? It's still going the same. Vx is the same. It's going to be constant, and I'll talk about that in a second. It's a component of the acceleration. And then, but what's happening here, right? So look, the arc distance of the length, right, changed. So my Vy is slightly different. And then what about here? Right? There's no velocity in the y direction here because it stopped, right? When I threw it up and out, it had a moment where it stopped and then went down. So here, it just has, oops, not that way. It's straight across like that. It just has the same length. Ooh, I drew that in different lengths. It has the same Vy. Again, the Vx, because it's going to be constant throughout our motion. Right? Let's analyze it in the same spot, right? Across, because it's a parabola, right? So let's do it right here. I still have that same Vx, but what's happening here? It's not going up anymore. Now it's going down. So my Vy, so now it's not 0 anymore. It has some Vy component, but it's the opposite direction, right? It's the same length, but opposite. So that's my Vy. And now let's analyze it here too, right? This is from the beginning, right? Where we have, it looks like a lot of Vy. So our Vx, like we said, is constant. And then our Vy is the same length here, but the opposite direction. Vy. So do we see that? Same points across the thing, but opposite direction. Now let's take a moment. Take a pause. Pause the video right here, and let's think about reasons why the Vx is constant. So now that hopefully you paused the video and thought about it on your own, let's analyze this Vx component and this mystery as to why it's constant throughout our motion. The reason for this is because the only thing, after I gave it its initial velocity, the only thing acting on that little ball of graph paper that I threw in the recycling was the acceleration due to gravity, right? So it's commonly known as g, but let's just call it that. 9.8 meters squared, right? The only thing acting on the ball as soon as I throw it is on the Vx in that direction, right? It's just gravity, 9.8 meters per second. Okay. So let's talk about that acceleration, right? So the only thing, what did I say? The only thing acting on it is that 9.8 meters per second, and it's usually negative, right? So it's going down, it's going down. So let's analyze the motion using that, now that we have this information, right? So what makes up this acceleration, right? Because, like I said earlier, it's vector components, right? So it's made up by the tangential acceleration plus the centripetal acceleration, right? But those are deeper topics for later. But just so you know, that's what makes it, again, follow this arc length. So let's do that. So let's say here, at this point, what's acting on it, right? It's getting pulled down. It's going that acceleration. So let's draw that. This is A, right? Whoop. What about here? It's going down. A. What about here? Right? Now this has no V, right? So the only thing acting on, no Vy, right? So the only thing acting on is pulling down. B. Oop, not V. A. Same thing here. A. So, and they should all be the same length. I don't know why this one I drew shorter. So now, right, now that we know that A is pulling it down in these things, we have a trick to analyze our motion, right? So we see here the A and the Vy, right? They're in opposite directions, right? We have the Vy is going up, right? And then our A is facing down. So what's happening here? As soon as I throw it up, right, when the velocity and the acceleration are going in opposite directions, what's happening? The ball is slowing down, right? The motion is slowing down. slowing. Right? So let's talk about here what's happening. So it's going slow, slow, right? Because they're in opposing direction. And then here we have no more Vy. So the only thing we have here is the Vx and the acceleration pulling it down. So the only thing it can do is change direction, right? So here at this point it's changing direction. Right? And then what about here? Now the acceleration and the Vy are in the same direction. So slow, 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 change direction. What's happening here? So if Vy and Va are opposite and slowing, what's happening when they're in the same direction? And then A, you guessed it, it's speeding up. And it's doing that here too. So, how are we going to analyze my throw again? So here, in conclusion, right? Slow, slow, change direction, speed, speed, and then it's in the trash can because I'm an amazing shot. So there, we analyze the throwing a ball, 2D motion, the projectile. Now everything is summed up nicely. So our first example is us throwing a ball. Let's explore other examples where projectile motion is used. In physics labs, right, there's a very common lab, right? The professor will tell you, right, to roll a ball off a table and then predict the exact spot where it's gonna land, right? So like X marks the spot. So you have a ball, right, and you whoop, 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 it's falling down. Right. So we have to analyze the motion of this ball, right? So you're gonna roll it off with some initial velocity, right? It goes off here, and the only thing right after you release it, right? The only thing acting on it as soon as it falls off the table is the acceleration due to gravity. And what did we say the velocity is made up of? It's made up of an x component and a y component. And since you only launched it horizontally, its only component is Bx. It's not acting. It's tangent to the motion of your object, right? So it's going to be imagine I drew them the same way, right? And then it's just like acceleration due to gravity until you can predict that one spot. So you initially roll it with some velocity, goes horizontally, and then doot, 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 and then you can predict using your kinematic equations and data collected where it's going to land. That's example 2. So far, when analyzing 2D motion, we've talked about rolling a ball off a table. We talked about me throwing a wadded up piece of paper into the recycling bin. Now, let's talk about another example, right? Let's say I'm a clown physicist, right? Clowns launch themselves out of cannons. They play with cannons for our entertainment. But let's say I'm a very curious clown, and I want to know the physics behind what I'm doing. So let's say in this experiment, I have equally sized cannonballs, right? The one in the cannon is the same mass as the one here, right? Let's say I'm going to launch at the same time from the same height horizontally, right? This cannonball from this cannon as I'm going to drop this cannonball, right? So the same height, same mass, right? The only difference is how it's being dropped. So let's analyze this motion, right, in our two-dimensional thinking, right? So I'm gonna light it, and it's gonna come out. It's gonna go like this until it hits here, right? And then what about here? At the same time, I'm gonna drop this ball. So let's analyze the components, right? So as soon as I launch it, because I'm launching it straight horizontal, the only thing it has is, as soon as it leaves, right, it's like it has V initial, and as soon as it leaves this cannon, the only thing acting on it, again, is gravity, right? It's just getting pulled down. This acceleration is getting pulled down. And then it just has a horizontal velocity, right? because that's the only component I gave it. And it's tangent to the motion. And these are all equal length. Okay. What about here? It's going straight down, right? And what do we notice here from the way I draw it? They end up hitting at the same time. I drop it here, I launch it there. They hit the ground at the same time. Because why? The only thing acting on this is the up and down, is the acceleration due to gravity. Is at 9.8 meters per second. What's the only thing acting up on here? Is this acceleration. There you go. 3 examples. 3 reasons why 2D motion works and how to analyze it. You have these skills now. Congratulations.